Okay, let's take a look at another stress strain question. The reference for this one is it's coming from your Chapter 6 assignments, and it's question number 1. And once again, this is another kind of very tricky question that I've took out the exam bank that a lot of people get mixed up with it as to which way around it is. So let's go through it and take a look at it. I've knocked up a little diagram here of my two 19mm bolts supporting a load from an overhead beam of 7,255 kilograms. Now, according to the question, we're only allowed to put 112,740 kilopascals on our bolts. That's it. Now we want to find out then what safety factor would have to be applied in order to actually do that. So let's first of all work out what our load is per bolt, because I like to always work in a singular. So with regards to that then, we can say that my load per bolt would be equal to my 7,255 kilograms and then divide that by 2. That will now give us 3,627.5 kilograms on each bolt. We can now go ahead and turn that kilogram mass into an actual load or a force by using weight is equal to mass multiplied by gravity. The mass of 3,627.5 multiplied by gravity of 9.81 meters per second squared. And that now gives us a load or a force of 35,585.775 newtons. So there's our first step. The next little bit to work out is figure out what area is on one of these bolts, because all the time I'm thinking about that stress formula of stress equals load over area. So we might as well go ahead now and get the area of one of these bolts. So using our formula for a circle, which is what the bolt area will be if you look at it in cross section, the area is equal to pi d squared over 4. Now, when we stick the diameter in, you can either choose to leave it in millimeters and get an answer in millimeters squared, then convert it to meters squared, or I'm guessing most of you prefer to convert the millimeters into meters right now. So this is going to be 0.019 meters. So let's put that into the equation. Pi multiplied by 0.019 meters squared and divide that by 4. Now, if you're unsure as how to turn 19 millimeters into meters, just put it into your calculator as 19 and then divide it by 1,000, and that you will get your number of 0.019. So once we've got that then, and we push that through our calculator, we come out with a very small number of 2.835 times 10 to the minus 4, and that's going to be in meters squared. Now again, don't worry too much about the exponential at the end there. This is kind of like doing a scientific notation that you would have covered in school. I've simply written down the number that my calculator showed me on the screen. Now once I've got that, I'm thinking about that stress formula. So as I mentioned earlier, the formula for stress is equal to the load divided by the area. The question, however, is what actual stress am I working out here? In other words, am I working out the ultimate stress, or am I working out the allowable or the working stress? Well, in this particular question, we're going to apply a safety factor to the load in order to ensure that we don't exceed 112,740. So in this example, we'd actually be working out the ultimate stress of the actual bolt. So the load on the bolt we found earlier, that was over here, of 35,585.775. Then we can divide that by the area that we just found above there of 2.835 times 10 to the minus 4. If we now push that through the calculator, we end up with 125.523 megapascals, where mega is 10 to the power of plus 6. I'm now thinking then about my safety factor formula. And the safety factor formula is that the ultimate stress divided by my allowable stress. Now, if you think about the concept of that, the ultimate stress has got to be higher than the allowable stress. So once again, you can see, looking at my numbers here, that if the allowable stress in the question is 112,740 kilopascals, and I've just worked out 125.523 megapascals, then my 125.523 megapascals must indeed be the ultimate stress. So once we've got that little bit cleared up, which is where all the confusion comes in for this question, by the way, we can go ahead and stick it into the safety factor formula. And so my safety factor formula is equal to my ultimate stress, and we can divide that then by my allowable stress. Now, from what we worked out earlier, my ultimate stress is my 125.523 megapascals. So 125.523 megapascals. Divide that now by my allowable stress, which was given in the question. And it clearly states it in the question that indeed it is the allowable stress on the bolt of 112,740. So once again, that's just more reinforcement that the stress we calculated must have been the ultimate stress. Now, the only slight problem here is that the stress in the question, given as 112,740 kilopascals, we need to convert that into megapascals simply because I've wrote this number down here in megapascals. And we can't divide mega by kilo. It has to be the same units. So we either have them both in kilopascals or both in megapascals. Well, I'm going to choose to work in megapascals. Well, 112,740 kilopascals in megapascals is 112.740. We've simply moved the decimal place to the left by 3 places, or you could think about it as dividing through by 1,000. If we push this through the calculator now, we come out with 1.113 for our safety factor. And indeed, not much of a safety factor, but that's the one that we would need for this system. So hopefully that clears that one up if you were having problems with it. Watch out for this one. It's a tricky little one that pops up more often than not, just because of that confusion between the allowable stress and the ultimate stress. So take care for this video, and I'll see you again for another one real soon.